First of all, for the abstract. Abstract first is global internet censorship, such as DPLI, DNS, and spoofing and IP blocking, is rising under the guise of security, which several threatens digital freedom, open communication, and basic digital insight. Second is identify the several ethical, social, and socio-economic ramifications of these information banners, focusing on decentralized infrastructure and advanced encryption protocols such as blockchain, power VPNs to circumvent state-level firewall and enhance privacy.
Internet computing refers to the use of the internet to store, process, and share information worldwide. It supports many daily activities such as online learning, communication, social media, and online business. Internet censorship and access restriction occur when government, school, workplaces, or internet services providers limit access to certain online content. While this can improve security and reduce harmful content, it may also restrict freedom of speech and access to information.
Net problem description. This topic discusses internet censorship and access restriction. It refers to the control of online information through website blocking and content filtering. Although its issue for improved security and public order, it can sometimes create problems for internet users. One major issue is overblocking. This happens when AI filtering system mistaking blockchain and useful website. As a result, users may lose access to important information and their digital freedom may be affected. Several stakeholders are affected by internet censorship. Government create and enforce policy, while ISPs implement filtering system. Content provider may influence website description, and internet user may face restricted access to information and slower internet performance. Next, the internet plays important role in education, communication, and daily activities. Therefore, encourage AI censorship can limit access to valuable information. Validity online security and freedom of information remain a key challenge in today's digital society.
We are conducting a technical analysis of internet censorship and access restriction. Let's begin by looking at the core technologies currently being used to enforce this limitation globally. First, we have artificial intelligence (AI) and machine learning. This technology enables large-scale surveillance and content monitoring by automatically detecting and filtering prohibited material, such as tracking social media or flagging hate speech. Next is blockchain technology. Due to its decentralized network architecture and lack of a single controlling authority, blockchain is structurally considered censorship resistant. However, it still faces challenges, as network participants can remain vulnerable to government and regulatory pressures. Finally, cloud computing plays a massive role by storing and processing immense amount of data. This infrastructure allows government to enforce content restriction and execute large-scale data analysis directly through cloud providers. This case study focuses on the Great Firewall of China, one of the most advanced internet censorship system in the world. It used technologies such as deep packet inspection, DPI, DNS poisoning, IP blocking, and machine learning to monitor and filter internet traffic. As a result, many global platforms like Google, YouTube, and Wikipedia are inaccessible in China. While it helps the government control online content, it can also increase network latency and create a separate digital ecosystem within the country. So, what drives nations to implement this restriction? The underlying causes generally fall into three categories. First, technical causes, mainly centered around cybersecurity protection to block malware and phishing, heavily relying on DPI to identify prohibited content in real time. Second, economic causes, aimed at protecting domestic digital industry, reducing dependence on foreign platforms, and boosting local tech companies, though this can reduce foreign investment. And last, ethical causes focus on protecting society from harmful elements like misinformation, hate speech, or terrorism, which is deeply tied to national security and political stability. Looking at the global statistical overview, countries like North Korea, China, and Iran enforce heavy censorship, often justifying it through this exact lens of public safety, political stability, and national security. To wrap up, internet censorship has a profound double-edged impact on our world. On the positive side, it can shield users from the cyber threat and foster the growth of local tech business. However, the negative consequences are steep. Technically and economically, heavy filtering result in slower internet latency, blocks crucial research resources, and limits global market access. Ethically, pervasive AI surveillance severely threatens digital rights, curtails freedom of expressions, and restricts open access to information. Ultimately, balancing internal security with global digital freedom remains one of the defining technical and social challenges of our era. Our second case study focused on Iran's internet control mechanism. Iran operates a national information network known as the NIN. During periods of unrest, authorities utilize BGP route manipulation and centralized network control to filter traffic and disconnect users from the global internet and redirecting them instead to the domestic network. While this keeps critical internet infrastructure running, like banking system and government portals, it heavily restricts international communication and isolates users from the global web.
For the proposed solution, first is advanced VPNs with traffic obscurations. How it works? It wraps your encrypted VPN data inside stranded HTTPS traffic to the firewall. Your VPN looks just like normal online shopping or Netflix streaming. So this is great because it's super user friendly with zero complex setup. For the onion router network and snowflake bridge Tor, the problem is what if authority completely block known VPN IP address? So the solution is the TOR network combined with Snowflake bridge. So it works instead of connecting to a public to server, it can connect to temporary process run by a regular volunteer worldwide using WebRTC. So this is great because this connection point change every few minutes and mimic normal video or audio call. So they are virtually impossible for firewall to track or block. Next, we move to blockchain-based decentralized domain name system, DNS. The problem is ISP use DNS spoofing to redirect your web requests to government warning pages. So the solution is the decentralized DNS using blockchains like Handshake or Namecoin. So it can work by replace centralized server with a global peer-to-peer blockchain ledger. Domain ownership is controlled entirely by cryptographic key. So this is great because it can decentralize. No government or ISP has the technical power to hijack, alter, or shut down website directories.
One major concern is data privacy, as users may be monitored online. Another concern is algorithmic bias, where AI systems may incorrectly block useful or legitimate content. There are also sustainability concerns because censorship systems require large data centers that consume significant amount of energy. In addition, different countries have different internet regulations, so organizations must comply with local law while respecting user rights. Overall, internet censorship has both positive and negative impact. Therefore, a balance is needed between online safety, privacy, and freedom of information.
Conclusion. The findings show that internet censorship can accidentally block the safe content, which limit access to information and affect digital freedom. This project helped develop skills in data analysis, understanding internet technologies, and evaluating solutions to digital issues. To reduce overblocking, advanced technology should be used AI system should be more transparent and digital rights should be protected.